All right, hello again. So in this video, I'm going to go over lists and other sequences. This video is going to, again, repeat a lot of the examples from the course text, but I thought it might be helpful to go over some of them verbally and well as let you be able to sort of see some of the stuff in action to hopefully help that, let it sink in and really clarify. All right, so let's, mouse, come back. There we go. Let's get ourselves started. Okay, so when we're talking about lists, in Python, a list is an ordered sequence of values that all get stored inside of a single variable. Effectively, it lets you create a variable that will have more than one string or more than one number sort of all combined together. For example, we could have a variable names that can be a list of 4 different names. We write lists inside of square brackets, so we're going to put brackets around the edge of it, and then we're going to use a comma to separate each individual value that goes inside of there. So this is going to be 1, 2, 3, 4 strings inside the names list. I could have a letters list that could have 3 letters. I can have a numbers list that contains 1, 2, 3, 4, 5, 6 numbers, and so forth. Lists can have lots of different types of elements in them, so I can actually mix and match them. So I can have lists that contain both strings and numbers and booleans and even other lists. Or lists can be empty, they may have nothing inside of them. I'll note that doing this kind of combined list isn't very common. Most likely we're going to have lists of all of the same type. So lists of strings, lists of numbers, lists of booleans, and so forth. Good. So the most important thing to remember when you're creating lists and you're working with lists is to make sure that you name them very carefully. In particular, you want to name the variables you use for lists as plural words, as meaning multiple different values. So this is going to have an S on the end in English. So if we have a list of names, we want to refer to that, call that variable names with this hard S at the end. We don't want to just call it name because a name refers to one thing, right? That's one name. But this isn't one name, it's a list of names. So we'd have lists of names, numbers, letters, things. We want to be able to have all those different pieces together. Alternatively, naming them something like number list or list of numbers is also a really good way of clarifying what's going on. But you really want to make sure that your variables that represent lists, you name them such as they seem like they're going to have lots of things inside of them. This will help make your code easier to read. It'll really help with trying to, when you hit strange bugs and things aren't doing what you expect, you'll be able to realize why it's not doing that because, again, you're helping keep track of what type of thing you're working with. All right, so we've got our list. They've got a bunch of different values inside of them. If we want to refer to individual values inside of a list, we do that by referring to the element by its index, effectively by its position in the list. So what we might do is if I have a list of vowels, and notice that S there, if I want to refer to the E, I might say that E is at position number 1. Its index is 1. In computer programming, and in Python in particular, we generally start counting list indices at 0. So the first element in my list is going to be at position 0. The second one will be at position 1. The third will be at position 2. This is because of the way computers end up storing numbers, so zeros end up making more sense as a place to start. You can think of it a little bit like it works a little bit the same way that that floor numbering works in Europe. So that you have the first floor is the ground floor, or I'm sorry, the ground floor. The thing that you go in off the street is the ground floor, the 0th floor, and then if you go up one flight of stairs, you get to the first floor. Same kind of thing here, right? The element without going any further is going to be 0, and then if you go up over one element, then you get to element 1. Cool. I often will find it easier to talk about and talk nail these things, talk about this as being the 0th element, the 1th element, the 2th element, the 3rd element, and so forth. But it's also easier just to talk about things in terms of that this would be the element at index 0, element index 1, element index 2, and so forth. The other metaphor that I'm going to use a lot that tends to make a lot of sense for thinking about this is that if you often think of a list a little bit like a hotel or an apartment building, we can think of that building as having lots of different rooms inside of it. So maybe this is a hotel that has 5 different rooms in it, and those rooms are numbered 0, 1, 2, 3, and 4, and then we can talk about who is the element that lives at room number 0, and that's an A. Who lives at room number 1, that's an E. Who lives at room number 2, that's an I. Who lives at room number 3, that's an O. This lets us be able to, again, talk about sort of the idea of an element that sort of exists at a particular spot, which we can then refer to and change as we go. Okay, let's go ahead and let's see this in action. All right, so we can access these individual elements. We can go to figure out what room they live in by using what is called bracket notation. What we're going to do is we're going to write the name of the list that we care about, and then we're going to, like for example down here, we're going to write the name of the list we care about, followed by a pair of brackets with then the room number, the index that I want to access, that I want to get at inside of that list, inside of those brackets. So for example, if I have a list of names, I've got Sarah, Amit, and Zong, which I can print out, and again, it looks like a list. If I want to access the element at index 0, I want to say what name, what value lives in room 0. I would put names, bracket 0, close bracket, and then that value, this expression right here would refer to that value. I could then assign it to a variable like name first, and then be able to print that out, and it'll print out the first or the 0th name in my list. I'll note that we don't need to even assign it to a variable. If I wanted to, I could just use that expression directly, the same way that you could just use a string directly or a number directly. You wouldn't have to actually, you don't have to assign it to a variable, and we get the same kind of result if we do that as well. Similarly, I could access the element at index 2, which, as everyone look, what element's going to come at index 2? That's right, it's Zhang. It's not Amit, right? Because remember, we started at 0. So Sarah's 0, Amit is 1, and then Zhang is going to be number 2. If you try to access an element that's outside of the list, this is going to produce an error. So if I go ahead and try to access names bracket 3, notice there is no element 3, there is no room 3 in my hotel, right? My hotel only has rooms number 0, 1, and 2. So if I try to go say who lives at room 3, then I'm going to get an error, which actually is fairly readable error. It says the list index is out of range, right? It's out of bounds. You tried going to a hotel room that doesn't exist, and so you get an error because the Python doesn't know what to do with that kind of work. I'll also note, because it tends to be it's Pythonetic and it sort of shows up a lot, is it's possible to use a negative number for an index to say what room number you're talking about, and that will actually end up counting backwards from the end. So if you use -1, then that's going to effectively say, let's start at the end, sort of outside of my list, and go back 1 element to Zhang. That's the last element. If you go -2, that'll count back 2 elements to get to Amit, and so we can be able to print this out and see if that gives us Zhang and Amit. -1s are great for being able to, the negative indexes are good for generally if you want to talk about the last element, because then you could just put the -1. Note you can't do 0 because that's the first element, so you go 1 back from that, -1, and that's a good way of being able to talk about the last thing as well. I'll also note that it's possible that the thing that goes inside of the brackets can actually be any kind of expression as I want. So if I want to say get me the names at room number 1 + 1, the way Python is going to interpret this is it's going to take that 1 + 1, it's going to add them together, it'll evaluate that expression, which gives me 2, and they'll say, okay, great, give me the element at room number 2, which is our Zhang again. Alternatively, I could do something like say, let's take the names of my list, the length of my list, to figure out how many elements there are, and there are 3 elements, but remember 3 was outside of bounds, so if I actually subtract 1, then that will give me the effectively, again, that last element of the list. That gives me my Zhang again, and as you can then see that if you sort of took this piece out, if you just got rid of that length entirely, that's where that -1 value comes together. So knowing which element you're accessing is a little bit like saying, get me the length, and then adding in whatever value I want to put inside the brackets. All right, and then when we're using the bracket notation, these are referring to values, expressions, the same way we would any other kind of code. So we can include this inside of any other code we'd want. So for example, I could print out hello, and then concatenate it with a string, like any other string. And in this case, I would concatenate it with names 1, right? We can say, let me get the the variable I want to concatenate it which will be whatever value lives at room number 1 of my hotel, and then I can then say hello to Amit. I'm gonna put a space there so that I feel a little better about it. Great. So similarly, because this names index 1 is effectively a variable, right? That's basically saying it's a label, it's a way of referring to a value who happens to live at that particular spot. We can also be able to assign new values to that particular variable, to that structure that exists. So for example, I can say, let's take names in bracket 1. So it's going to be effectively referring to the room that is room number 1 in my names hotel. And I can assign a new value to that. We can say, let's have this value, Yash, actually go ahead and have that value end up sort of being assigned to that variable, and effectively say that person will now move into the hotel and begin living there, and basically replacing the Amit variable and kicking him out. So if I do that kind of assignment, you can then see that if I reprint out my list, then now Amit has changed, right? The value that used to be at index 1 is now gone, and it's now been replaced with Yash. So effectively, it's a little bit what's going on here. It's a little bit like we're trying to say that we had a variable that was like names1 was Sarah, and names2 was Amit, and names sorry, I didn't take this out ahead of time. Names3 was Zhang. But instead of sort of defining 3 separate variables and having to sort of list all these different values together, what I can sort of do is say, well, let's take name, I guess this would be 0, 1, 2. What we can do is we can say, let's sort of group all these pieces into a single list. All right, we'll put them all together. And put them all together. And then instead of having to talk about printing out names bracket 0, I could just name names sort of the 0th, that random variable. I would be able to then say, let's refer to the person who lives inside that hotel. Let's go into room 0 in order to figure out who we want to then deal with and who we want to access. This video is not quite as polished, but I don't really have time to go through and re-edit everything and make it all come together. So hopefully this will work out okay for the moment. So the other thing that you can put inside of the bracket when referring to or accessing a list is going to, rather than just a number or an expression that evaluates to a number, you can also put in what is called a slice, which you produce using what's called the slice operator, which is a colon. The way that you generally will write that is you'd say that inside the brackets, you're going to put effectively the range of values you want to include. So you'd say that I want to get the values from index 1 through index 3. And you put a colon between them to say go from 1 to 3. Now, because of the way that lists are specified, because they all start at the 0 index, the value at the end, right, the sort of the thing after the colon is going to be non-inclusive. So if I say that I want values 1 to 3, then that's going to give me 2 values, which is like 3 minus 1, but it's going to say start at value 1, include that, get value 2, include that, get to value 3, and then stop. Don't actually include it, but go ahead and just stop it anyway. Similarly, you can then do other variations on that. So if you put a starting value, but you leave off the ending value entirely, you just leave it blank, then the Python interpreter will say, great, that means you just want to go to the end of the list. So you don't have to put in like colon length of list, or you don't have to even put colon, you don't know how long the list is. So I can say start at element 3, 0, 1, 2, 3, there's my D, and it'll just go D, E, and F and get all those pieces together, and that'll then produce this sublist, this sort of chunk of the list that I want to get out as well. Similarly, I can leave off the starting value, which means start at 0. So basically you can put 0 to 3 or just colon 3, 0 colon 3, or just colon 3 without the 0, and they mean the same thing. So again, we're going to start at 0, 0, 1, get to the 3, but that gets left off because we're not including that. If you put negative values, they can get negative values from the end. It works sort of the same way. If you actually leave off both values and you just put a colon, that's going to then get you all the elements. So we're going to get A, B, C, D, E, and F. However, that's going to give us a new list that contains those same values. So effectively, it's not giving us, it's making a copy. It's like cloning and duplicating that list, which is occasionally sometimes useful. In practice, slicing is good for if you want to get sort of chunks of lists. It's a way of getting sublists of things, but it's not super common. We use it occasionally. Often you'll sort of end up we talk about slicing off a value. So you might say, get me from 1 to the end or 3 to the end, and that way effectively you're getting all the stuff at the end, but you're slicing off, you're sort of cutting off the beginning of the beginning of the list. Or you might say, I want everything but the last 2 elements, and you sort of slice off the last 2 elements. All right, so we can use bracket notation to be able to assign individual elements into a list, to be able to say, take this value and go put it inside the hotel where it needs to go. If you want to do more complex modifications to the list, so for example, you actually want to change the shape of the hotel, you want to do some other work, you actually want to remove rooms, you want to add more rooms to it, you can end up doing that using methods. So these are going to be functions we're going to call on the list. So we're going to use the dot notation to do that. So we might say, for example, if we're using the append function method, we're going to say letters dot append. We're going to call it letters append function, same way that we call things like to upper or replace on a string. And we can do that to be able to then modify these lists. So for example, if I have my list of letters A, B, C, D, and I want to add another 5th room to this, right, a room at index 4 that contains somebody else, if I want to add that extra room, I can use the append method to do that, which will go ahead and add a new element, creating a new room for it, basically like making things add-on room and being able to put the element inside of there. And if I do that work, you can see that I then get A, B, C, D, my original list, which now has this extra A on top of it. The thing to note here is that I'm not actually returning a new value or assigning this to a new value. I'm literally just modifying the existing value that's already there. Other things we can do. We can insert new values into the middle. So if I insert an element at y at index 2, that's going to shift everyone else over. So we now get our y's at index 2 and everyone else gets shoved over. I can remove elements from the end. So if I pop someone off, then that's going to remove the last item of the list. It removes that last item, and then the letters.pop function will actually return that item is. So if you don't know what you removed, you just said, hey, give me the last guy, then it'll return that so you can see what that value happens to be. So there, our x is now gone. I can also remove from the middle by popping out number 2. So that would, for example, remove that y, gets us back to our original list as well. If you want to remove a value but you don't know what its index is and you want to basically figure out where it lives, there is a shortcut method that'll do that. There's a remove method where you can specify the value you want to remove. So I want to remove the C from the list. Notice that nothing actually gets returned from this. So the letters.remove function doesn't return the C for us to use later. It returns nothing, because the assumption is that if you were searching for a C to remove, you know what got removed because it was the C. That's what you were looking for. And of course, if you want, you can remove all the elements by clearing the list, and that will then produce you an empty list at the end. Now your letters are gone. Yeah. All right, so the thing to note is that, again, is that these list functions, list methods, very rarely actually return anything. What they do is they're going to modify the hotel, they're going to modify the list without necessarily returning anything new for us to work with. So for example, if I call the append function on letters, that'll have an effect. It'll add a new room and add this X to my list of letters, but it won't actually return anything. So if I ask what it returned, it's going to end up returning none. This is very distinct from how string methods end up working. So remember, with strings, if you had something like replace or concatenate or upper or lower, those would take the string and give you a new string instead, right? Strings are immutable, so you can't actually change the existing string. You have to produce a new different one instead. So with a string, I would say, take my string. If I want to then replace all the L's with M's, go to the next letter up, then I would have to do that, but that, again, won't actually modify my message string because strings can't change, so I'd have to take that return value and save it where it used to be. And then I could do that in order to get the hemma wormdud. If I then, of course, print out my message string, my original piece, remember that now has not been modified. What the string methods do is produce a new value. List methods will often change the existing value without trying to modify something later. So this distinction about whether you're modifying a list or producing a new different variable becomes really, really significant, particularly when we're dealing with functions. And particularly functions that take in lists as arguments. So just like a function can take in a string or a number as an argument, a function could take in a list as an argument. So here's an example. So imagine we had the function that's going to add a z to a list. So it gets passed in a list as an argument, and then what it does, it takes that list and it appends the z. Remember, append will modify that value. So what we're doing is we're saying, here's this function, I'm going to hand it a hotel, and it's going to go ahead and add on a new room to that hotel. So if I take some letters and I add a z to them, in the end, I'm going to get my letters variable, right, is now, my hotel has now effectively been added onto, it's been extended, so it now has extra letters on it as well. Compare this to a slightly different version of the code, which I'm just going to paste in here because I'm in a hurry. No, that's spacing. So this is a version that adds z to a local variable. So what it'll do is it's going to be a slightly different function, named it a little bit differently. We're going to take in a list, right, so we're going to pass it in a hotel again. And what it's going to do is it's going to actually take that existing list, add another list to it in order to basically create a different hotel. So it's like we're going to take in hotel 1, take in another little addition, and when we add them together, it doesn't create a brand new hotel, or it doesn't modify the existing hotel. It's going to create a brand new hotel somewhere over there. And we get this other new hotel called list with z. Right, that's the sort of it's like the new special hotel we've created. But we can then say, oh, but I really wanted my original hotel, right, that A-list hotel, right, to actually be the list with Z hotel. So what we're trying to then do is we're going to say, let's take that sign that says A-list in big, shiny, glowing letters, and we're going to go hang it on the list with Z hotel, right? We're going to move that sign over. So ideally then, when I can print out my letters, it should basically produce the same effect. But what you notice that happens is that it doesn't actually do that. Because what happened is that this A-list sign is just a local sign, right? It's sort of like the sign that's only inside of the single guidebook. It's not actually the sort of whole, it's not built into as part of the hotel. It's just a label we use to refer to that. So it's like this would be the favorite hotel. If I then go ahead and create a new hotel and move my "this is my favorite" label to somewhere else, I've moved that local "this is my favorite" label, but that doesn't actually do anything to modify the list that has the letter sign on top of it. When I go ahead and use an argument, that's creating effectively a new sign that I'm hanging on my hotel. So I basically say I took this hotel, ABC, when I passed it into the function, I'm going to hang an A-list sign on it. I've then taken that A-list sign and moved it to somebody else, but this letter sign that was originally hanging on this ABC will continue to hang on that ABC, so it doesn't actually modify anything. As opposed to then up here in this example where I took my letters thing, I hung an A-list sign on top of it, but then I said go to the hotel that has an A-list sign and add a new room without necessarily moving the sign over to anywhere else. So again, it's this distinction between am I actually modifying a variable, or am I taking that value and taking that name tag, that variable, and moving it to a different value somewhere else. With strings and numbers that are immutable, we are moving values, we're moving labels to somewhere else, but with lists, because they are immutable, we often might be changing them without moving the variables around. That's probably a long, sort of confusing explanation. This is a little bit tricky, and it's mostly just sort of a weird bug that shows up if you're being uncareful. The best way to avoid this is to avoid doing this kind of thing. Don't try to take variables and assign them to new lists. If you want to modify an existing list, it's better to be able to actually use something like append or insert or remove. If you do want to create a brand new list, then do that, but give that a brand new variable name to keep track of the fact that it is, in fact, a brand new different list, right? So it's the difference between what are the actual hotel buildings and then what are the signs that we're hanging up on those hotels about who should refer to what and where and when. I actually haven't checked how terribly these quick cuts sort of throw off video stuff, but again, I'm just trying to record stuff because I'm in a hurry and I don't have time to. And again, getting this online course set up for the first time. So anyways, we're going to clean it up as we go. All right, so the next example I want to go through is the fact that lists can have lots of different kinds of elements, right? They can contain numbers and strings and booleans, but lists can also contain other lists. We can have a list of lists, which can actually then be a list of lists of lists if you really wanted to go for it. These are referred to as nested lists, right? It's a list inside of a list, also, or potentially a 2D list, depending on sort of how you're talking about things. So here's my example from the course text, which I want to walk through because it's good to see it in action. So here's a list called dinner options. We can tell it's a list because it has a bracket around it, right? We're assigning it equal to some bracket. We then have sorry, my mouse is wrong. 2, 3, 4 elements inside that list. You can tell because there are commas separating these 4 elements. Each of those elements happens to be a list, it's defined with brackets, and inside those inner lists, again, notice the text here, the inner list versus the outer list, but inside these inner lists, I then have 3 different string options. So for example, my first element of my dinner options is itself a list of 3 strings, chicken, mashed potatoes, and mixed veggies. So again, if I check to see how many elements are in dinner options, it's not going to count up the number of strings, it's going to count up the number of elements in dinner options, which are the number of those lists inside of there. So there are in fact 4 dinner options, even if though I've got 12 different strings inside of values sort of inside this list of lists. Because dinner options is a list, I can use bracket notation to access it. So I can say, get me the element index 2 out of that list. So again, this is index 0, 1, 2. So that's the fish option, right? Fish, seasoned rice, and green beans. I can take that element number 2, that list, assign it to fish option. If I print it out, then I'm getting out this list. So the element number 2 of my dinner options list of lists is going to be the list inside of it. So again, if I say I've got a list of things, those things happen to be lists. Because fish option is a list, I can of course use bracket notation on it as well to say, well, get me the first element out of, the 0th element out of my fish option list, which is of course the word fish. Awesome, great, we've got fish in there as well. Cool. So the trick here then, so again, part of the way is just trying to think through, okay, am I dealing with the outer list, right, the sort of the list of dinner options, or am I dealing with a list of actual like food items, which is then I have a list of lists. So I've got my dinner options are actually going to be a list of collections of food items. And so thinking about that sort of that nested structure is going to help you deal with some of these more complex, larger data sets, which will do a lot for when dealing with things like tables or dealing with things like large data sets, the kind of things you just put in a CSV file or an Excel file, or often get structured as these sort of lists of lists. Okay, the syntactic piece I wanted to make sure to note, though, is that fish option here, remember, it's a name tag that I'm hanging on this particular value, dinner options value 2. So because the fish option is effectively an alias, it's a name tag for this particular value, I can actually take that value, I can, well, if I can't do it here, I'm going to do, I'm going to, oh, there it is. I'm going to copy this, and then I'm going to take fish option, and I'm going to literally just paste in and replace that with the value the name tag is for. So it's like instead of using the alias, I'm going to put in the actual value that we're really actually caring about. And then again, if I execute this cell, and I notice I execute again, I get the exact same result because I'm doing the exact same thing. Just instead of using the shortcut name fish option, I've used dinner options bracket 2. What that did do, though, if we then step back a step, is that this is let me define, effectively, let me access an individual value, an individual string inside of this list of lists by using this sequence of bracket notation. So I've said go to dinner options. So the way that we sort of read this and understand it is it says go to the dinner options variable, that's this guy, then go to element 2 of that, which is this guy, then go to element 0 of that, which is this guy. So that basically lets me specify how I can dig deeply into one of these lists, but without having to necessarily assign a bunch of intermediate variables along the way. I'd be able to talk about going to dinner options to index 2, index 0. This gets used again for tables. If you think of this as sort of like a table of food, this tells me, say, go to row number 2, column number 1. We can do the same kind of thing if we want to then be able to modify or update or adjust these lists. So for example, maybe my dinner options index 2, element 0, I want to assign a new value. Instead of fish, maybe we're going to call this, we'll call it salmon. We'll be more specific kind of fish. I can do that as well. And now if I go look at my dinner options now has salmon at that particular element. You might also see this with calling functions. So because dinner options 2 is a list, I can say append a new value to it. So maybe I could say let's give him a cookie. So maybe you get your fish and you also get a cookie as dessert. So I can do that as well. And then if I go output my dinner options, then there's my cookie down here at index. An element is assigned as an extra element of list in a list that living in sort of in room 2. If you want to really extend the hotel metaphor, you can almost think of this as this is my hotel, and these are the floors. So there's floor 1, floor 2, floor 3, floor 4, and then each floor has 3 rooms, 1, 2, 3. So when I get here, this says go to floor number 2, and then go to room number 0 of floor number 2, which works out pretty okay, actually, if you go with the hotel metaphor. This kind of thing is useful when you start dealing, again, with these nested structures in order to be able to make all these pieces come together. All right, so the last piece that I want to note for dealing with lists in this part of this video is that lists are only one kind of sequence in Python. There's actually lots of other sequences that all work very similar to lists. They just have their own slight details or quirks about them. Lists are the most common kind of sequence that we're going to use the most often in Python, so that's usually a good default to go to, but there's other sort of options and values there as well. All right, so one of those are, in fact, you've seen before, which are strings. Strings are sequences of characters, of individual letters, the same way that lists are sequences of any arbitrary value at all. So if I define myself as string, like message string, hello world, I can be able to do things like access this with bracket notation. So I could say, let's go to my message string, and I could say, get me the 0th element from that. Just like I would say, get me the 0th element from a list. And if I do so, that'll get me the H. I'll get me the first letter from that value. I could even, if I really want to, I could go access pieces of it. So I can use a slice to say, get me a substring starting at index 0 of 1, which is the E, and then going up through index 5, which is going to be through the O. Because again, 0, 1, 2, 3, 4, 5. So it's the 5th thing. That's what I want to keep. That lets me get the LO part of hello. So I can be able to sort of use that to get, this is how you get substrings, how you get pieces of strings in Python. I think I had a demo of this in the previous video, and this is where that stuff works. There are string methods that actually deal with indexes as well. So for example, there's a find method that'll tell you what index a particular letter happens to be at. So if I want to know where is the W of my hello world, I can do a find W for that, and it'll actually, message string, and that'll tell me that the W is at index number 6. So that if I then said go to my message string and asked who is at index number 6, then that gives me the W. And then finally, if I want to actually take this string, which is an iterable, if I want to convert it into a list because I want to do things like modify the individual characters, or I want to append new things to it, or I want to otherwise pretend that it's not just a string but a hotel, I can actually do that by using the list function the same way in order to convert my string into a list. So I can take my message string to make it into a list, and that'll then give me a list of all the characters from that string. This is the same kind of way that we would take numbers and turn them into strings, or take strings and turn them into numbers. We can now take strings and turn them into lists as well. So we can keep changing back and forth between these types by using these functions that are named after the types. Okay, so those are strings. So strings are one major sequence that we're going to be dealing with. The other kind of sequence we're going to deal with are what are known as ranges. I don't have a slide for this, so I'm just going to go ahead and type it out by hand. A range is going to be a sequence of numbers, of integers, basically from 0 to some value. We define these using the range function, which you see turns green because it's a built-in function. So if I say range of 10, then that's going to produce me a range of numbers from 0 to 10, right? Because it's going to, by default, start at 0 and then take me up over to 10. You'll notice that it prints it out as a range. It doesn't actually tell me what numbers are inside of there. So if I then say print out this thing, it still only prints it out as a range. If I want to then actually see what values are inside of there, what I would need to do is I need to convert it into a list, the same way we convert a string into a list. So I would say, I'm going to put some spaces just for readability. So I'm going to say take that range, right? This is my range, and I'm going to then convert it into a list in order to then print out the values inside of there. And we can see that now that my range was actually a sequence of numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'm going to paste this one down here for a second so we can see what range 10 will look like. So I want to note that range 10 says it goes from 0 to 10, but the numbers included here are only 0 to 9. The reason that is because when we specify the ending argument for a range, that value is not included. Similar to how with a slice, how that ending value is excluded, it's not inclusive, the same thing happens with ranges. So if I say, the reason this works is because if I say range 10, then what that's basically telling Python is that I want a range of 10 numbers, right? I want there to be 10 different things in my sequence. I want that range to have a length of 10. But because we start at 0, 0 counts as 1, so we have to say there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my 10 elements. I don't actually have room for another element as well. So if I want my range to actually go from 0 to 10 and include 10, I actually have to have my range be 1 higher. So I have to basically go 1 higher than what I want the last number to be. So this would take me, if I say range of 11, then that'll give me 0 through 11, counting the values that I actually want to have. What I'll often do when I'm coding is I'll actually write out my range as being 10 plus 1, which tells me that I want there to be 10, that's the last number I want to include, and then the plus 1 makes sure that that we add in the extra value to be able to get me to that extra piece. Great. Okay, so with it range 10, that's only going to go up to 9. Range actually can take a number of different arguments. So if you just give it one argument, it's going to go from 0 to the value you specify. If I give it 2 arguments, say 3 to 10, then it's going to give me numbers, counting up by ones, starting at this value inclusive, going up to the value that going up to the second argument. So this is going to give me values from 3 up to 10, but again, that 10 is not included. So if I take, so this is going to produce 10 minus 3 or 7 values, 1, 2, 3, 4, 5, 6, 7 values. Great. If you include a third argument, you can actually specify how much you want to, what's called the step or skip argument. So this might say that I maybe want to say start at 3, go up to 10, but I want to take only every second value. So it's going to say go to number 3, and then we're going to skip 1, and then we're going to go to 4, and then we're going to skip 1, and then go to 5, it's going to go to 6, then we're going to skip 1 and go to 8. Effectively, that's going to give me only even numbers, or odd numbers, I guess, right? So we go to 3, we're going to skip 1, gives me 5, skip 1 gives me 7, skip 1 gives me 9. So if you want to create sort of a range or sequence of values that are moving, that are sort of jumping layers, you can do that as well by sort of adding more and more arguments to range. In practice, this is going to be the most common structure we're going to use, is we're going to use a range from 0 to some particular value, but occasionally you need to be able to modify stuff if you want to say start at 1 or start at 2 or end a little bit earlier than you expected. You might want to tweak the edges of those ranges as well. Stepping is not super common, it's just kind of fun. Great. what do I want to say about this? So ranges are useful if you need a really quick sequence of numbers, right? So if I want to get all the numbers from 1 to 100, if I want to do 1 to 100, I can start typing a list, but that's going to take me a really, really long time. That's going to get very tedious. If I want to instead use a range, I can just say, great, give me the range from 1 to 100, and then adding 1, make sure I get 100 on both sides. Boom, I have my range, 1 to 100. Right, there's all my numbers. This is a sequence, so if I want to get the fifth number from that, I can do so, right? Fifth number will be one at index 6. It will be the 6 because, again, we're starting at 1. If I want to actually see what all those values are, I could go ahead and convert it to a list, and we'd be good. And there's all my numbers up to 100. Go me. Great. Okay, and those are the major sequences we're going to start with. Lists are going to be our main sequence, and then we're going to use ranges to represent sort of the special case of ranges of, the special case there's going to be sequences of numbers. There are other sequences built into Python as well. In particular, we'll talk about tuples and dictionaries in a later module, but those are later, so at the moment you can just focus on dealing with lists and then ranges, which are sort of our special kind of list, and that'll get you where you need to go.